for section 2.6 of your BJU Press Geometry textbook. We're going to learn about subsets of space. So our objectives is we're going to identify the difference between a surface, a closed surface, and a solid. We're going to look at a definition of a sphere in terms of a center and a radius. We're going to define cone in terms related to cone. And we're also going to look at the definitions of cylinder, and prism and pyramid. So let's start with the definition of a surface. A surface is a connected set of points only having the thickness of a point. So this is just the surface. This is just the surface. So there's no volume yet. It is just the thickness is just a point. So this would be an example of a surface. Here's another example of a surface. So notice that this is just this shell. It doesn't include anything inside the shell. It's just the outer part or the surface. Here we have a sphere. Now when we think about the surface of the sphere, we're not counting what's inside of the sphere. Think of a basketball, right? A basketball, if you think about what it's made up of, it's just the plastic on the outside, right? The inside is full of air. So when we're thinking about surface, it's just what's on the outside. So the definition of a sphere is a surface in space, and it's consisting of the set of points at a given distance from a given point. What that means is that you have a center, right? A center of a sphere is that given point where everything on that sphere is the same distance from that center. Think about the center of a basketball, okay? Well, the basketball is the same size from the center of inside the basketball. And then you have what's called the radius. The radius of the sphere is a segment that connects a point of the sphere with the center. So let's look at the sphere again. So you can see the center, and then there's the radius. So again, inside is the sphere does not include what's the inside. The sphere is a surface, right? So when we talk about the sphere, we're talking about this piece here, the outside piece, the shell, right? What's called the shell. But in order to figure out where that shell is, we have a center on the inside and a radius to tell us how big that shell is. So now let's take a look at what a closed surface is. A closed surface is a surface with a finite size that divides other points in space into the interior and an exterior. So remember that very first thing that I showed you of a surface, and it was kind of wavy? It wasn't closed because it was just in space, but it didn't really divide anything to interior and exterior. Versus the sphere was closed because it closed off everything and had an interior and an exterior. So as you can see, the surface is just the surface is just the outside part. But what if we wanted to include what was inside? We would get what's called a solid. A solid is the union of that closed surface and everything that's inside that closed surface. That's when we get a solid. Okay, so again, we're going to include the inside. A cone is the union of a region and all segments that connect that region or the boundary of that region with a specific point that's not on the same plane. So for example, here we have plane K. On plane K, we have this region B. Okay, what we're going to do, we're going to take the boundary of region B and we're going to connect it to this point that's not on plane K, point A, and we're going to connect every point on the boundary of region B and connect it to that point A. And then we get what's called a cone. Now, if our region was a circle, we get what's called a circular cone. And then we have something called a cylinder. A cylinder is the union of two regions of the same size and shape in parallel planes, and the set of all the segments that join corresponding points on the boundaries of those regions. So here's an example. We have two planes, and these two planes are parallel. We have a region in plane 1, and in plane 2, we have a region that is exactly like the region in plane 1, and they're parallel. So if we were to connect all the segments to the corresponding points, we would get what's called a cylinder. So a cylinder or a cone is circular if each base is a circle. A prism is a cylinder with polygonal regions as bases. So anytime you have a polygonal region, you have a prism. So here we have pentagons. So we have a pentagonal prism. Then we have what's called a pyramid. A pyramid is a type of cone, right? And this cone has a polygonal region as its base. So this is what we would call a right pyramid because it makes a 90-degree angle versus an oblique pyramid that doesn't have a right angle. Here we have a triangular prism. And then we have a hexagonal pyramid. Now this hexagonal pyramid is regular because the hexagon that it's its base is a regular hexagon. Well, that's all we have for this one. Go ahead and attempt the problems.